All right, welcome wonderful people. Today we're going to be utilizing all methods of solving quadratic equations and select the best method for a given quadratic equation. So factoring is probably, well, in my opinion, for most problems, it's the easiest. Now, certain methods work better with certain types of quadratic equations, right? There's not really a one fits all approach. Okay, they all have their strengths and weaknesses against certain kinds of problems. So with factoring, what we want to do is we want to get everything onto one side. Now, in this case, it does say to factor, so we don't need to think too much about what's the best kind of method to use. But so for factoring, what we want to do is move everything to the opposite side, all the way to one side. So here, well, these are not like terms, so I cannot combine them. Since they cannot be combined, I'm going to go ahead and squeeze the negative 6x in here so that the negative 7 moves over to the right. And it has to be set to 0 so that we can use the zero product property. Now, we need to factor it. So for factoring, we need to use our method that well, again, this is the method that I generally use, and it can be used with most types of quadratics. Sometimes you need to solve by trial, which means you just keep trying things until something works. But in this case here, I think we can manage to use the reverse FOIL method. So we're taking the number apart opposite the way we would do with FOIL. So what we start with is the last number of our quadratic, which in this case is negative 7. So I need two numbers that will multiply to negative 7, which there is only one set of factors that I can think of that will multiply to 7. Now it needs to multiply to negative 7. And remember that a positive times a positive is positive. Oopsie. Is positive. There you go. And a negative times a negative is also positive. But the only way to get a negative is if you have a negative times a positive, which means one of them is going to be negative. Now we could, let's see, which one would be the positive and which one is the negative. So we could check it really quick. So what we're going to do is we're going to look at the outside and inside, the OI. And what this is that it is a way of adding them to see whether or not we can get negative 6. So 7 minus 1 is positive 6, not negative 6. So this means this is not the right combination. So all I have to do is switch this over so that this side is now positive and try again. So 1 times negative 7 is negative 7, and 1 minus 7 is negative 6. So there we go. Now we have our parenthesis groups filled out. So x plus, and let's test it really quick. X times x is x squared. Negative 7x plus 1x is negative 6x. So it works so far. 1 times negative 7 is negative 7. So when we use FOIL, it still works out. Okay, now what we need to do is use the zero product property. Zero product property says that whenever we multiply, because remember, these are two groups being multiplied together, what can we put in for x that will make it 0? So in this case, 0 is not going to work because 0 plus 1 is 1, and 0 minus 7 is negative 7, and neither of those are 0. So what you could do, and you don't have to do this sometimes, you know, but what we're going to do here is we are going to set two equations, both equal to 0, and then solve each of those equations. So in this case here, I got minus 1, and I'm going to minus 1 from both sides. X equals negative 1. So I got one of my solutions. And for this side, we're going to use our inverse property again. So if it says to -7, we're going to add 7 to both sides. So by adding 7 to both sides, I find that x is equal to 7. And now I have both of my solutions. So there are two solutions to this one. So again, if you see a square or an x square, that is possibly, okay, so possibly there are two solutions. Sometimes there can be one or no solutions, or complex solutions, imaginary solutions, radical solutions. Okay, well, I don't want to worry you, but most of those we're going to cover today. Well, we already covered them. This is more of a review. So what we need to do now is write our answer in set notation, because we have a set of solutions where one is -7 and the other solution, wait, did I say -7? I meant to say -1 and 7. So here are the two solutions for this that we have. So if I were to plug in -1 back into the original, okay, so -1 squared would be 1. 1 minus 7 is -6. And equals on this side would be 6 times -1, which would still be -6. So -6 equals -6. That makes it true. If I plug 7, it should be the same thing. I get 49 minus 7, which is 42. On this side, 6 times 7 is also 42. So 42 equals 42. That is true. These can also be graphed as well, but we will not cover graphing in this lesson today. Maybe I'll touch upon it. Now, looking at this problem, my opinion would be I would not use factoring on it, okay? But it says to use factoring, so we're going to go ahead and do factoring anyway. So I'm going to do something, I don't remember what it's called. I think it's called AC method. And what you do is you multiply this times that. So you kind of move it a little bit. You can also use a solve by trial. Now, solve by trial is one that I did cover. I have covered solving by trial previously, and that is basically you just keep trying things until something works. But sometimes that's not a good idea, because 4 and 24 have a lot of factors. So you would try things like 1 and 4 or 2 and 2. And then for 24, you would put inside of the bubble things like 1, 2, 3, 4, 6, 8, 12, and 24. So those are all the factors you would try with that one. And you can tell that's probably going to take a while of guessing. So again, AC method is you multiply the A times the C method, which is this 24. And now we're going to factor it here like this. So by factoring it, okay, so same thing, look at your last number, start with the last number first. So let's see, 96, I'm sorry, we want 96. So I need two numbers that will multiply to 96, but will add up to 5. So if you're kind of stuck, sometimes you can make a factor list and just work your way up. So 1, 2, and I need, okay, so 2 times what will give me 96? So that's 48. And then 3, okay, so but they got to add up to 35. So 2 and 48 would be 50, which we need 35. So let's try 3. So that would be 32. 3 times 32 is 96, and 3 plus 32 is 35. So we take care of our inside numbers. So x, oops. Well, we can take care of our first because we already know what numbers there are. Now, there's also the thing about the signs. If your second sign or the last number sign is positive, that means these two signs will be the same, okay? Meaning that they will both be positive or they will both be negative. But in this case, when they are the same, they will be the same as whatever the first one is, or the first operation, or your middle number. In this case here, we have 3 and 32. Now you may remember that we times by 4. And one thing in math is that you never really get something for free, okay? Free is just not a word that we use all that much. So it's more like borrowing. Whenever we move something, or I'm sorry, whenever we change something, or we have to move it somewhere else. So essentially what we're doing is we borrowed the times 4, but now it's time to collect on it. It's time to get it back. So what I need to do is divide both of the factors by 4. Now, this kind of helps out a little bit because if I were going to factor it using the solve by trial, that is to keep guessing things, it would be really hard for me to get 3/4. And like I said, this is not a very good one for factoring, but this is just one other method, and I would like to have covered it a little bit more. Maybe in the future I'll cover it a little bit more. I'm just sort of working with my materials that I'm changing to this year. All right, now we have to solve. So that means to get the x by itself. So we do the inverse on both sides, and I think we're ready for our solution to be shown. So in this case, it's x equals. Our first solution here is going to be, well, if I want to put them in numerical order, I'm going to put -8 first, and then -3/4. And again, this is not a really good solution for working with with these kind of problems. You know, I mean, if I looked at that, I would have gone straight for a quadratic formula. But that's me, though. I mean, some of these you can use more than one type of method for. Others will require other types of methods. All right, moving on. So using the square root method. Now, using the square root, now this is like closer to what you might think of when you have regular algebra problems. All right, if you have a regular ordinary algebra problem where you're kind of having to multiply or divide both sides and that kind of stuff to get an answer, it's going to be similar to that. Now, the thing that makes this one, what makes it a good candidate is there is no b value. The b value, if you remember, is the lone x. So we have a x squared, we have a regular number, but we do not have the middle number that we call the b value when a quadratic is in standard form of ax squared plus bx equals c. So in this case here, there is no x number. When there is no x number, that makes it a little bit easier. Well, I don't know if it makes it easier, but you can use the square root method. And using quadratic formula with this one, it works, but you're going to be missing a lot of stuff. So I -2 to both sides. Now in this case, I'm not going to set it equal to 0. I'm going to set them equal. Oops, I almost forgot this is the square here. I'm going to set them so that I'm trying to solve for x. Like I said, more like a traditional type of algebra problem. Divide both sides by 10. And I get x squared equals 28. All right, 200, I mean, they both end in 0, so just take out the 0 really. Now I want to get this x by itself because this is x times x, remember? So I'm going to take the square root of both sides. And that gets rid of the square because square and square root are inverse operations. So x squared equals now, in this case here, 28 is not a square number. If I were going to try to take the square root of 28, and let's see, square root button. Oops, that's not the square root button. This is the square root button. Okay, I'm not sure. Well, I'm pretty sure that I managed to push the combination of buttons in the wrong way to get the same right answer, but oh, I guess it is 5.29150. Now you get a whole bunch of numbers here. Okay, you get a whole bunch of numbers, but the definition of a square number is two numbers that multiply to get the number you're looking for. So in this case, we're trying to get 28. Now, if I were to go with 5.2 times 5.2, oh, come on, what is going on with this thing? 5.2 times 5.2, I get a number, well, this is below 28. Okay, well, what if I add more numbers? 5.29 times 5.29. I get 27.9, which is even closer to 28. But we're not quite there. if I were to add more and more of the numbers that we had earlier, we would get ever closer to 28. So here we got 27.99. That is really close. And the more digits I add in after the decimal, the closer we will get to 27. But unfortunately, we can't get to 27. We'll get 27.999999, but we can't actually get there. So that's why we have to use this, the notation, radical notation, simplified radical notation. So I need to think of two numbers that multiply to 28. Let's see, we can go with 2 and 14, but neither of those are square numbers. So what we could use, trying to look for square numbers, is 4 and 7. So that's root 4 times root 7. I already know what that's going to be. Now we can take the square root of 4, which is going to be 2. Now, oh yeah, watch out, because in this case, this is the one where we need to consider the positive and the negative option. So that's 2 root 7. The reason why we need to consider a negative option is just an example really quickly. What if I said, what number, if I square it, can give me 9? Almost anybody's reaction will first be 3. But don't forget, -3 times -3 will also be 9. So that's why we have to consider the negative option. So there are two possibilities. Now in this case here, we are completely solved for x, and we have a simplified radical in both the positive and negative option. All right, so we just need to put our answer in the solution notation. And again, solution notation means that it is a set, because we're not looking at one answer, we are looking at two answers. And this is a real number. It is irrational, but it is a real number. You just get that weird 5.291415, 0 whatever number that we had earlier. So it does have both of those numbers in there. Anyway, let's go ahead and go to this one here. So same thing, I want to get this by itself because it says to use the square root method. So we should be able to use the square root method. Now in this case, these are both negative. So a negative combined with another negative will make a larger negative. So 6 plus 0 and 5 plus 16 is 21, so 216. Minus, because they are both negative. Now, we got to get rid of as much as we can to get that x entirely by itself. So let's get rid of this, and it'll cancel our 2, so we have no 2 anymore. And here I got 216 divided by 2, which is going to be negative 108. All right, take the root of both sides. And let's see, oh no, it looks like we're going to get a imaginary number. So remember, the imaginary number is equal to a negative root, or root of -1. So root of -1 times, I need to think of two numbers that will multiply to 108. Now, if you are not sure what numbers can multiply to 108, one thing you can do is just make yourself an entire factor tree. Just factor the whole thing out. So 2 times 54, and 54 is 2 times 27, and 27 is 3 and 9, and 9 is 3 times 3. And now what you want to do is take out your groups. So that's, I got a group of 2s and a group of 3s. So I'm going to put them back together. So I got root 4. And here I have 3 times 3, which is root 9. And they're multiplied to each other. So don't forget that they are multiplied. And here I have root 3. So this is what it looks like if I were to take the number all the way apart. Now again, multiply all 4 of these together. You will get negative 108 back. X equals positive and negative. So let's start with our whole numbers. This is 2, right? Because square root of 4 is 2. So 2 times 3. 2 times 3 is 6. Take out the imaginary variable I because root negative 1 is I. And times it by the square root of 3. Put it into our set notation. And we are done with that one. Okay, next one, completing the square. I don't know how this one compares to the other methods. It has its uses, it does. But it says to use completing the square, so maybe on some of these you probably wouldn't choose completing the square method. But let's go ahead and do this one here. So when you're using completing the square method, now this is not a really tough rule, but the best thing to do is not have an a value. So in this case, again, no a value. So x squared, oopsie, plus 12x. And we leave a space here. Leave a space, and 7 minus 3 in this case is 4. And okay, now what we got to do is we got to put something in here to make a perfect square trinomial. So a perfect square trinomial is kind of like when you have 2 matching groups. Okay, now they can be positive or negative. You know, you can have x or whatever, but whatever is in the bubbles, the parentheses, have to match. Okay, so they got to be exactly the same, because when you put the groups together, oops, I think I meant to put b, but I almost wrote 6. They will make a square. So again, perfect square trinomial. So it's a square. Anyway, so this is the one where you have to follow the steps. So you get your b value. Oops, not. Sorry, they're right next to each other on the keyboard. B value. So you take it, half it, square it. Oopsie. Take it, half it, square it. Okay, so let's go ahead and get our b value, which in this case is 12. So take it, half it, square it. So in this case here, I need to put 36 in here. Now, I can't just go ahead and change anything in the equation. All right, this equation needs to balance out. Just like a balancing scale, if I add 36 pounds on one side, I must add 36 pounds to the other side so that it stays balanced. Because I can't just change one side. Now, if you're converting to vertex form, you're going to have to do the same thing, but you're going to have to kind of minus the same side. But in this case, we are not converting to vertex. We are trying to solve by completing the square. So we get our perfect square trinomial and 2 numbers that multiply to 36. And again, they must match. So 6 and 6 is the way you get 36. And again, this means they will be the same if it's positive, and that means they will both be positive. Now here I have, let's see, 6 plus 6 is positive 12. Okay, that works out. And our first number is going to be x. So now I have 40. Now, kind of just just to save myself a little bit of space, sometimes I might skip this step here that I'm doing right now to show that it's a square, right? Because again, if you multiply this together, it's just a square number, squared group, I should say. And take the root of both sides. So take the root here, take the root there, and I have x plus 6 equals plus and minus root 40. Now, in this case here, I'm going to break 40 down into two numbers, with one of them being a square number. So in this case, I have root 4 and root 10, which we can take the square root of 4, which is what I'm going to do. So x plus 6 equals plus and minus 2 root 10. And I cannot break 10 into any other numbers because the only factors that make 10 are 2 and 5, which neither of them are square numbers, and I don't have enough of any of them to, change it to anything. So now I only have one thing left to do, and that is to minus 6 from both sides. So let's go ahead and write our answer. I think we're ready to show the answer. So that is x is equal to the set of negative 6 plus and minus 2 times the square root of 10. And again, if I were to plug this into a calculator, I would get a big old long repeating number, which is why we use radical notation. And we are done with this one. I kind of noticed that I'm sliding over this way, so maybe I'll be able to do this one now. Okay, now this one here does kind of have a bit of a problem. It does have an a value, but it is a completing, it tells us to complete the square method. So, oh boy. All right, so I'm gonna get this 38 out of here. So I'm gonna add 38 to both sides. 6x squared minus 12x and leave a space equals 38. Okay, now I know what someone might say is let's do the take it, half it, square it thing, which in this case we have negative 12, which would mean negative 6, and then negative 6 times negative 6 is positive 36. So let's drop the 36 into both of them. Now I'm thinking that it might actually work, but an easier thing to do is to divide everything by 6. Oh, this looks like it should be 48. As I look at it, I notice it would be 48. Okay, because everything should divide by 6. I knew that that should have worked out that way. And now we have x squared minus 2x, leave a space. And in this case, 48 divided by 6 is 8. There you go. Now I need to drop something in here to make it work out better. So we grab our b value, so take it, half it, negative 1 times negative 1, square it, you get positive 1. So plus 1 here, plus 1 there. Now to save space, I know that when I factor it, I'm going to get two identical bubbles, and I'm running out of space, so I am going to already factor them. I'm just going to imagine that there's two bubbles here. If you want to write it and erase it, or in this case, if you want to write something all the way out, go ahead, do it. I would say work whatever works best for you. Now I need two numbers that multiply to positive 1. Negative 1 times negative 1 is positive 1. To get my middle number, negative 1 combined with another negative 1 is negative 2. And there you go. So I'm just using my regular methods. Take the square root of both sides, and I get x minus 1 equals, in this case, I can take the square root of 9, and that would be 3. And I end up with adding 1 to both sides to solve it. Okay, so I also, when I do this, I could break it into two equations, but I have barely enough space to write my answer, so cancel here. Let's go ahead and take positive 3 plus 1. Positive 3 plus 1 is 4. Let's consider the negative option. Negative 3 plus 1 is negative 2. So those are my two solutions. Negative 2 and 4 are the solutions I'm looking for. Okay. Now on to the next type of method. And that would be quadratic formula. Quadratic formula is pretty good, okay? Quadratic formula is like the big hammer. It's like the big tractor. It works every time, and it will pretty much work on any job you want it to work on. However, it just like a big tractor, it would require more gas to run it. So even if you were to have, a construction site, they wouldn't use the big tractor all the time because it costs more money to operate. So what, well, let's see. This is kind of a hard one because you will have two possibilities. You got to remember it. This is the big downside to quadratic formula, and that is you have to remember how to work it. You have to remember how the formula works. Oops. And this is a really tough formula. I would imagine that a lot of people, a lot of students would not memorize the entire formula because it is a very difficult formula to remember every single thing. It has a lot of stuff in it. There is a lot going on. But there is the quadratic formula. Now, if you're taking a test, it is possible to remember the quadratic formula. However, if you make anything wrong, oopsie, oh, I have to draw this part in myself. There you go. If you make an error in the formula, then everything after that is not going to make any sense. So that is the downside to quadratic formula. The other downside is that it does take a long time because you have to put multiple numbers into the formula. But anyway, let's go ahead now. But when you use the quadratic formula, you must make sure that it is in standard form. So x squared, x to the 1 power, x to the 0 power, or in other words, no x. So it must be in descending orders of x power. Okay, so this one is ready to go. And this is not good for factoring because you have a 5 here, or you have an a value. So it's not good for factoring. It is not good for square root because you have a b value. It is not good for completing the square because again, that a value gets in the way. So in this case, completing the square is pretty much, quadratic formula is pretty much the only option we are left with. So let's go ahead and fill it in. So negative 4, because we grab our b value, which is 4, but it is negative when we put it into the formula. Negative 4 plus and minus 4 square minus 4 times a. So our a value in this case is 5 and 1. Now, I probably, if I were working on this myself, I would leave that 1 number out because it does get confusing when you have so many numbers on at once, okay, in the formula at once. And then 2a with our a value is 5. Okay, there we go. So we are ready to start evaluating this. And I always start with what we call the discriminant, which we covered in a previous lesson. Our discriminant is all of this here. So I have 4 squared, which is 16. And let's see, 16 minus 4 times 5 is 20, and 20 times 1 is 20, okay? So in this case, I got 16 minus 20, which is going to be -4. So I'm going to go ahead and put -4 in here. Now, that's the other thing about the quadratic formula is that it has a lot of steps. This is not necessarily a bad thing, but again, I do run out of space in some of my, while working on some of these problems here, because I only have this much space to write on. All right, now what we have to do is, we have a negative in our radical. So the discriminant in this case is telling us that we will have an imaginary solution. So no other method can get you imaginary solutions. Well, actually, I think completing the square can, but maybe square roots can. But quadratic is the best at finding something if it has an imaginary solution. So again, I'm going to take out the negative. Take out the negative from the radical, and I am left with I. Now we have root 4, which actually, you know, we can take the square root of 4. So I'm going to take out the square root of 4, which is 2, and I together. Now we're not quite done yet, because this is -4 divided by 10 and 2i divided by 10. It looks like a fraction, so we are, actually it is a fraction, so we are going to do what we do with fractions. If we cannot divide them, we will reduce them. Now there's also another part missing to this formula that I had earlier, and that is x equals. So the reason why there are no x's in the quadratic formula is because we took all the x's out. So anyway, now when this is all solved, we just work with only the numbers. And again, we got from here, we've got to reduce it. So that's going to be -2 plus and minus. So I'm going to divide everything by 2. Divide that by 2 and divide this by 2. So 10 divided by 2 is 5. And there we go. That is the answer for that one. And again, I did skip a couple of steps. I'm sorry about that sometimes, but sometimes I'm just forced to. Anyway, let's go ahead and do this next one here. So I am going to move all of my numbers to one side. So again, you have to adjust the formula, because if I just plug in 5 as C, the negative gets lost and we don't have a negative anymore, and that throws everything off. You know, I'm probably going to end up with the wrong sign somewhere. So let's rewrite our equation. So -2x squared plus 2x minus 5, and that would be 0 here. Okay, and now we can plug our numbers into the equation now, into the formula. And again, this takes all the b's out, so, or all the x's out, so I don't have to worry about any of this solving of any kind. All right, so -2, and that's this 2 here, not that one. Plus and minus square root of b squared, so that's 2 squared. Now, if I were solving this on my own, I would just put 2 in there. Or I'm sorry, I would just put 4 in there just to lower the number of steps that I'd have to be working on. And our a value is -2 and the c value is -5. And again, these signs are important, okay? Don't be just leaving the signs out because you don't think they're important. They are important because they can change the meaning of everything. Okay. Now, let's go ahead and start evaluating this. So -2 plus and minus, let's see, 4. And in this case here, I'm going to go ahead and do each step at a time because this looks kind of confusing. Look at all these negatives. We actually have 3 negatives. So negative times negative is positive, but positive times negative is negative. This means that we're going to have a minus here. 4 times 2 is 8, and 8 times 5 is 40. Negative this part here, put those together. Negative 2 plus and minus root. Looks like we're going to end up with another negative number under the radical. And that means, again, we are going to have an imaginary solution. And remember, it's not no solution, because no solution means it will never cross. But in a parabola, now I'm not really sure exactly what this would look like, but my guess is something like that. That means that it's not going to cross. But if we change a couple of these numbers, then it will cross. Or if we change the direction of the parabola, then it will cross. Now, imaginary numbers are actually very complicated to explain. So I encourage you to do a little bit of research if you really want to know what imaginary numbers mean in the context of a solution for a quadratic. Okay, but anyway, back to what we need to cover at hand, 36. Okay, so 6 times 6, oh no, that's not going to work. So we're going to need something. So 4 times 9. Oh wait, never mind. Huh. Silly me. It is 6 times 6. So negative 2 plus and minus negative root 1 times root 36, which we can take both of those. Okay, so let's see, negative 2 and plus and minus. Now take the square root of 36, we get 6. And take the square root of negative 1, and don't forget I is equal to root of negative 1. That means we replace it with I and negative 4. All right, now we need to reduce this the same way we did on this one here. So all 3 of these are even numbers. Them all being even numbers means that we should be able to reduce them. Now there's also another thing that we have here, and that is we want to reverse the sign on everything. Everything has the sign reversed because I have negative on top and negative on bottom. Now this one doesn't matter because if I were to change the sign from positive to negative, the negative would also change to positive. So anytime you do a sign reversal like this, you can, well, just leave that the same. Anyway, 1 plus and minus, oops, I got to divide everything by 2. So that means this gets divided by 2. And this gets divided by 2. And now I just need to put it into the set notation that we've been using. Oh no. Okay, I hate to do this. See what I mean about running out of space? And again, some quadratics, they will have a lot of steps in them. This one had a lot of steps because there were a lot of numbers. There were a lot of sign changes, and we also needed to reduce things. So there was a lot of stuff going on with this one. So as it goes for quadratics, this one was, again, a pretty tough one. It threw pretty much everything it had at us. And you know, while I'm kind of at it, I'm also going to switch over to the Desmos really quick, just to kind of remind you what an imaginary solution looks like. So I'm going to go ahead and do number 7 that we had earlier. So 5x squared plus 4x plus 1. So it's going to look kind of like this. And if we zoom in, it's not crossing our x-axis. So it is not a solution. I mean, there's an imaginary solution, I should say. So again, it's not no solution. It's just imaginary solution. Anyway, let's go ahead and get back over here. And move on to the next exercise. So we're going to do another type of exercise, and that is choosing the best method. Now they want us to use each method only one time. So if we choose a method, we can't use that same method on a different problem. All right, so now on your assignment, you'll be able to see all 4 of them. So you will have a much better time choosing which one you want to use. So you'd probably want to start with the simplest one. Start with the one that you can factor. Which in this case, that's kind of a tough choice here. So let's go ahead and just go in numerical order. So for this first one, let's see what we're working with first. So I'm going to minus 10. It looks like I'm going to have to minus 10, but it looks like I'm also going to have to minus 3x from both sides. So 2x squared minus 3x minus 10. Okay, so factoring this is going to be hard because, well, we have an a value, and we could either use AC method, or we could just solve by trial and keep coming up with factors until we manage to guess it right. Or, well, I don't think that's going to work, actually. I don't think completing the square is going to work, or square root is going to work. Square root is not going to work because we don't have, we do have a b value, so that is not going to work. Completing the square, we have an a value, so again, that's not a very good candidate for that, which leaves us with only one option. Okay, the quadratic formula. That's the only option I think we have with this one here. So opposite of b, so that's going to be positive 3 plus and minus negative 3 squared minus 4 times a times c. Now, you can also check the discriminant on each of these too, and that is to only use the this part here. You know, you can do that similar to what we did in a previous lesson. You can just get this part here, and that'll give you what kind of zeros you're looking for. And if you're looking for irrational or imaginary solutions, then definitely use quadratic formula. Okay, so let's go ahead and work this out. So I'm going to do a little bit of the work over here. So negative 3 is, if I square it, I get 9, minus, and then 4 times 2 is 8. And that would be 4 times 2 is 8, and then times 10 would be 80. So I get, oh, you know what? I almost forgot to include the negative here. So that would actually be positive 80, which would mean that I would have the square root of 89 over 4. Now let's look at 89 and think, okay, can we break this down to simplify the radical? Okay, we can do 1 times 89, but 1 is, we don't really consider 1 a number that we can take out because of identity property. It's not even, so we can't use any even numbers like 2, 4, 6, 8, 9, or 9. 2, 4, 6, 8, 10. So that only leaves us with odd numbers, odd prime numbers. So 89 cannot be divided by 3 because 3 times 30 is 90. And if I go one number down, 3 times 29 is 87. So it's not divisible by 3, which means it's not divisible by 3, 6, 9, 12, or any other number that is divisible by 3. And it's not divisible by 7, 11, 13, or 19, or any other prime number. So in other words, we can't break down 89 at all. And since we cannot break down 89, I think that is actually going to be our answer. We cannot do anything more to this. So 3 plus and minus root 89 over 4. So we just rewrite that same problem. Oh my goodness, those are some terrible braces. Better, not perfect, but acceptable. Okay, so there we go. So quadratic formula is out, so that only leaves us with factoring, square root, or completing the square for this method here, for this problem. So let's see, we have no C value. Is there a method that works best when there is no C value? Now be careful, because factoring does not just mean the double bubble method. There is another type of factoring too. And in this case, me looking at this, I can see that it is a perfect candidate for what we would call, or I don't know what other teachers call it, but I call it the reverse distributive. And reverse distributive, we all know distributive property when you have a parenthesis, but what we're going to do is we're going to divide both of these by numbers that we know, and we're going to take that number and put it out front. So x times x is x squared, and 8 times x. So if I were to multiply these back together, 8 times x is 8x. So now I managed to get two distinct factors. I can put a parenthesis around this just to make it look like a group, so that it feels more like a group. So now we have our first answer, x is equal to 0. Now we also have to look for the second possibility, because again, there's always two possibilities whenever you're working with quadratics. So solve it, which in this case I only have to solve one, which is good. And x is equal to, and I'm going to put them in numerical order. So I'm going to put -8 and then 0. So our two solutions are -8 and 0. Nice. Close enough. So there we go. So we used up quadratic and factoring. So for our next slide, that would only leave completing the square and square root property, or using square roots. All right, let's go ahead and move on to that last slide now. There we go, the final slide. Okay, so both of these are not solved. So, well, I'd like to solve them, but sometimes you just can't really tell what the best method is. But you know what, let's go ahead and do that right now. I am going to -10 from both sides, and let's just see what we're working with. And I have 4x squared minus 49 equals 0. So I'm going to set it to 0. And again, we may have to change some of these later. Make sure whenever you're doing this, you do it to both sides, because sometimes I will get students that will accidentally do the same thing to both sides, and that doesn't really change anything. All right, so again, I have completing the square and square root property left. So this one looks like we may be able to get a square number out of it. So I'm thinking we should use completing the square. So I'm going to go ahead and add 49 to both sides. That's going to remove 49 from this side and move it to this side. Divide both sides by 4, because now in this case I'm just trying to solve it like a normal algebra problem. X squared equals 49 over 4. And I'm able to get x all the way by itself without doing any factoring. So that makes this one a pretty good method to use square root property with. So let's see, x squared equals, and then when you have something like this, it's going to look something like this if I were to work on it a little bit more. Square root of 49 over square root of 4. Okay. So that means I can take the square root of 49, which means I'm going to get, well, don't forget the plus and the minus. 7, and the bottom number is root 4, so the bottom number is 2. Oopsie. The whole reason I rooted the both sides was so I could get rid of that square. So now it is, well, gotten rid of. And actually, I think this is the solution. So let me go ahead and get ready to put it into solution notation, because we have positive 7/2 and negative 7/2. Now, just because this is a pretty good opportunity, I'm going to go back to the graph and look at it. Now, pay attention, because 7 divided by 2 is 3.5. So as I go back to the graph, I'm going to punch this in. So 4x squared. And originally, it was negative 39 equals 10, or minus 49 equals 0. But if I set it equal to, well, let's see, minus 49, we should get a parabola. Okay, it doesn't look like a parabola because it has a very great vertical stretch. That vertical stretch narrows the graph, so it is a parabola, it's just very narrow. Go back to the home screen and we can see that our x-intercepts are at negative 3.5 and positive 3.5. So again, positive and negative. So whenever you have anything that has that sign of the positive and the negative, that means you've got to consider both of those options. So positive and negative 7/2. All right, final question. Now that leaves us with only one method, and that is to complete the square. Okay, so when completing the square, I think what I'm going to do is I'm going to get rid of all that, because we don't really need it. But what we do need is a space here, and I need to find something to put in there to make it into a perfect square trinomial. Now there is also one big downside, and that is you cannot have anything in front of the x square, which in this case we have a negative. Luckily, there is an easy fix for that, and that is to multiply everything by -1. And basically all that does is reverse the sign of every term that we have. So everything is opposite. So positive, negative, or actually, yeah. Okay, now we got to do the thing where we get this b value, take it, half it, square it. And that means that all I got to do is add 1 to both sides. All right, now I am going to get a perfect square trinomial here. 1 times 1 is 1, but they need to add up to -2. So -1 and -1 will combine to make -2. And again, I'm going to go ahead and, since they are matching, well, you can test it out really quick, make sure it works. X times x is x squared, -1x, -1x is -2x, and -1 times -1 is +1, so that works out. And I'm going to go ahead and just erase one side so I can put the square here, so I can easily take the square root of both sides. Uh-oh, looks like we're going to get an imaginary number. So again, you can get imaginary numbers, I think, from both of these. Like you could easily get something negative under the radical in this case here. So I guess they are okay for, if you're pretty sure you're going to get an imaginary number. It's not, you don't have to use the one you're using. Anyway, take out the negative and it becomes I. Add 1 to both sides, and it looks like we're actually done. X is solved. So 1 plus and minus, oops, Almost forgot the plus and the minus on this step here. Don't forget that because it is easy to forget that. It is really easy to forget your plus and minus because you do have two solutions. Whenever you see a square on the x, that means you might have two solutions. Anyway, back to work here. I root 6. And I think we are done. Let's put it into the correct notation. And it looks like it's time for you to get to your next class. So that is it for today. I hope you enjoyed the lesson with me today. So that is it for today. I hope you enjoyed the lesson with us, and that will be, well, goodbye for now. Thanks for stopping by.